Okay.
Yay.
It's the.
We're back.
All right. So I will give everyone a copy of this. These are the derivatives of our inverse trig functions. So the integral is just going to go the other way, right? So these were the derivatives. So arc sine was 1 over square root of 1 minus u squared du dx. And cosine, arc cos, is almost the exact same thing with a negative sign. Arc tangent, 1 over 1 plus u squared. And then arc cotangent, same thing with a negative. Right? And then arc secant is 1 over absolute value of u times the square root of u squared minus 1. Arc cosecant, same thing with a negative sign. Now, the du dx is that if this is not just an x, it's a function, there'd be the derivative of the inside part. Yeah.
Aren't they supposed to? Oh wait, no, never mind. Never mind.
Is that why they
Never
had
mind.
D?
I see what happened.
Yes.
That's what I asked, and you were like, maybe.
So yeah, so for instance, if it's not a 5, not an x, it's a 5x, then it'd be multiplied by 5.
But no, I was talking about when we first learned these. I
They
was like,
use,
why
yeah.
are they used? And you wouldn't tell us. You know.
Russell
So
got
I don't know
it.
if that's the reason.
You
But
sound very salty right now. Is that so?
So the inverse is just the inverse trig functions just go the other way, right? So here are the 3 basic ones. The other 3 just add a negative to it, right? So if we have a function, the derivative of function over the square root of something, a perfect square minus u squared. So notice whatever this is, it's going to be the derivative of this one with the square on. Okay? And that's going to be arc sine. And what's going to, the value, arc sine of what? It's going to be this one over this one. The square root of this one, you can't even see me, I'm pointing. Sorry, people that on the tape can't see me. People here can see me. So the square root of this one over this one. Okay? So these are specifically formulas. Arc cos is identical to that. Except it's going to be a negative. And that would be arc cos. Okay.
is there theses in arc cos?
There is, unless it doesn't come out when I write it. And then same thing with, I think arctan is one of the easiest to pick out. But so we have the derivative of this one. And if it's just an x squared, that's just going to be a 1. And so you'll have a perfect square plus perfect square. And in the numerator will be the derivative of that second one. Yeah.
For 3, does the u in the denominator have to have the absolute value bars?
It might not have the absolute value bars, but it'll be positive.
Okay, because it's already given to you.
Yeah, yeah. So and then arc cotangent would be the same thing, except we would see a negative. So it'd be 1 over a arc cotangent u over a plus c. So these are really formulaic. You just have to learn the formulas. And then, oops, I just wanted to move this one. There we go. Move. There it goes. So I could squeeze the other one underneath there. And so then the last one would be arc cosecant. Oops, negatives. Do those go somewhere? Or there's just like 2 of them? Oh, I was underlining, that's why. They're not negatives. All right, so then arc cosecant would be the same thing except negative. Because this will be a positive number, the absolute value bars are likely not to be there. Okay? So then the negative would just be 1 over a arc cosecant. And then, but you include the absolute value bars, u over a plus c, if that's a variable. Okay? So those are our 6 formulas for the inverse trig functions. And so this lesson is just on the inverse trig ones.
So arc cosecant isn't different from arc secant? I think you said it was negative or whatever.
Yeah, if you negative.
See, I put the negative right there.
Oh.
I'll move this over so it's next to it. Yeah. So that's the only difference between them is the negatives. I'm going to, when we're all done with this lesson, tomorrow I'll print you out notes, so any writing will be on there. Yeah. So you don't have to worry so much about writing. Right, so let's put I'm going to write over here our formulas, right, so that we remember them. So I'll write down the basic ones, and we know if it's a negative, it's just going to be the other one, right? So I'll write down the 3 of them there. Or
Sine x over 2 plus c.
what's that? All right, actually, you know what? I'll write it down. So by the way, when you see the square root here, when you see perfect square, and sometimes they have to be created on perfect square, but perfect square, anything you could make a perfect square, and a perfect square and a minus, it's going to be the arc secant, right? The difference between, or arc sine, excuse me, the difference between these two, the arc sine and the arc secant and cosecants, are which is which, right? So this one here is a variable. U is a variable, okay? A is a constant, right? In the arc secant and arc cosecant, this one here is the variable, all right? So that's kind of like the basic, and there's something out there. But that's one of the differences between them. And then it's a plus. So how about this one? Which of the 4 would this one be? Or excuse me, 6 would this one be?
That could be the arc secant. No, arc sine.
Arc sine, yep. This one is arc sine. Okay. So remember the formula for arc sine, if we have du over square root of a squared minus u squared. This one's the constant, that one's the variable. It's just going to be arc sine, and it'll be a over u. Wait, no, u over a. I have to think which way it goes. Is that me?
Probably might be.
I think so.
Oh. And then if it's indefinite, it'll be a plus c. So this will include a plus c. I'll squeeze that over for plus c. Oops, come on, everybody move over. Right? All right, so we don't need to do any substitution on this one. We can just figure out the integral on this one. So what's our integral going to be?
I got this.
And actually,
It's arc sine x over 2 plus c.
you might, now this one isn't so difficult, so maybe don't need to do it on this one, but you might find this helpful, is that to make this a something squared, okay? Helpful hint, especially when it doesn't look like it could be a perfect square. So a helpful hint is to make each of these a something squared. It prevents you from making a mistake with a coefficient too. Make each a something squared. The only thing I don't like when I tape is that the board is so much slower. A something squared. Okay? So the 2 here is our a, this is our u, and this is just going to be arc sine x over a plus, excuse me, x over 2 plus c. Is our derivative. or excuse me, our integral. And let's make that a function. There we go. So it helps to learn the formulas. It's not a bad idea to have a table out in front of you when you're trying to figure out some things. And speaking of a table, I can probably give you a table of derivatives and integrals, as well as post a bunch of stuff for AP, little formulas and reminders and things like that. Any questions on this one? Yeah.
If we get tattoos of this, will we be like kicked out of the?
Probably.
Wait, what?
So yeah, do not.
Get tattoos?
One asked if you could get a tattoo of these formulas, and no, you probably should not.
No, there's a rule.
What if I say I got them before I knew I was taking the test?
Then you probably have
How
to
did you know
leave
the
it in
equation?
your arm or
How did you,
something.
how did you know the equation?
All right. So which one of so you get a little hint with this one. They're all going to be one of the 6 in this lesson. So which one of the 6 is this?
It's the cosine, arc cosine.
It's arctangent.
Yeah,
It's arc cotangent.
Oh, there's no square root sign.
Yeah.
You're so smart, Gino.
Even if it was cotangent, there wouldn't be a square root sign.
I didn't say cotangent.
I thought you said cotangent.
He said
No,
cosine.
No, cotangent does not have a thing.
Isabel Kimball to the office, please. Isabel Kimball to the front office, please.
This time, girl.
Control your system.
Like sister.
Oh.
So anytime we have a du, now this one might involve a substitution on it. Yeah.
If the 2 is a 1 instead, could it be both tangent and cotangent?
No, because of the sign.
What if the original function? Wait, no.
No.
That makes sense.
Oh,
Never mind.
yeah, that's right.
The sign's the problem.
Okay.
All right, so it'll be du, and this will be the a squared plus u squared is going to be arctangent. And it's always have to double check, make sure I don't put the u's and a's backwards on here. So for arctan, right, it's going to be u over a, but they're going to have a coefficient in front, 1 over a.
So a would have to be the square root of 2 then.
Yes.
Why?
1 over a, and then u over a. So the u is a variable in these,
You want us
and
to
a
move
is a constant. What's that?
Do you want us to move the radicals to the numerator if we can, or no? Or just leave them like that? Because if it's 1 over a, it's going to be...
Oh, no, just leave it. Yeah.
Leave it?
Yeah, you do not need to rationalize.
Oh,
So it helps to write this as a something squared. So this one is going to be the square root of 2 squared. This would be 3x squared, which is why I said it's helpful, because you might forget, you might put a 9x instead of a 3x. So it's got to be the whole thing squared, right? And this formula, by the way, takes care of our substitution here on this one. We won't need to do that because notice we'd be missing a constant, but the formula will take care of our missing constant first. All right, so what's our integral going to be?
1 over square root of 2 arctangent 3x over square root of 2.
And that's fine. Square root of 2, yeah. That's fine like that. Or if you want to rationalize it, it'd be the square root of 2 over 2 arctan 3x square root of 2 over 2. Either's okay. It's not that big of a rationalizing. So either's okay with me. Oh, plus c.
Do we have to...
Yes.
I think I
Do
know.
you want to fail?
Kinda. No, I'm just kidding, Miss Mashagna. Don't throw me out of the class.
Throw him out of the bus.
What are you doing?
Fight me, Riley.
I hope that you should throw him out of the class, if not for the reason Riley said, then for saying that he should get in a fight.
Yeah.
I'm not saying I should get in a fight. I'm
encouraging
saying that
violence.
he should fight me.
Which would imply you being.
I'm recording, Juan.
Oh,
one.
Right?
I blame Amanda.
All right, so let's look at the next one. So which one is this one?
Arcsecant.
Is
Yeah, it is.
Yeah.
Good job.
Because it's positive.
Yep. And we gotta notice something's out there. So let's refresh our. Let's look at the formula for arcsecant. So arcsecant, right, is going to be 1 over a. So now this is the second one is going to be the constant term here. Arcsecant, and then the absolute value of our square root here over our square root of our constant here. Okay. All right, so let's rewrite this. So this would be a 2x squared minus 3 squared. And so then what would be the integral?
1/3 arcsecant absolute value of x over 3.
That S looks bizarre.
It looks like an 8.
I know. So 1/3 arcsecant
Absolute value of
X
over 3.
over 3 plus c.
I'm just going to say that next. I just want to see if you guys would catch it.
Okay, so really it's most of this is just recognizing the formula and then just making sure it's a something squared. It just prevents you from accidentally putting a 9 when you meant a 3. Yeah, it's just that little step there. And be thinking one of the inverse trigs when you see the radical, especially if you see a radical in the denominator, or you've got a something squared plus a something squared. Okay, that's going to be kind of your clue that hey, maybe I should think about is it one of the inverse trigs. So now, which one is this one?
That would be arctangent.
Yeah, we haven't had a cotangent in here yet. Hasn't been a negative.
Had any cotangent
But they'd be the
cosine?
same except for we'd see the
Yeah,
negative.
plus 4 plus. Does that change anything or no?
No, because it's arctangent.
Yeah. All right, so let's
Oh,
rewrite this.
Okay.
All right, so and there's x. So this would be a 2 squared. This already is x minus 3 squared. Okay, and let's refresh our memory on the formula. At least the lesson isn't that long. I don't have to scroll through that many pages. Right, so for arctan, right, we're going to have, so it's going to be 1 over the constant term, and then our exponent, our variable over our constant. Let's just scroll to the page I need. Is it that one? Come on. There we go. All right, so what would our integral be?
1/2 arctangent x plus 3 over 2 plus c.
See this? So 1/2
Arctangent
arctangent
x plus 3 over 2 plus c.
x
X minus 3.
Okay.
Come at me.
Yep. So the nice thing about these is they follow a formula. We'll look at some that are the inverse trig functions kind of in disguise, though. And as soon as you know how to recognize they might be in disguise, then they're not too hard to figure out. Like I said, the radical is the dead giveaway that in the denominator that maybe, not always, but maybe it could be.
When you mean they're in disguise, is it going to be like they're normal except they have like a negative exponent or something?
Not necessarily.
Oh, okay.
Not necessarily that. Oops, I guess we have this twice. Didn't we just see that one? All right, so which... So now, yeah, because we have an x to the fourth minus 1.
Could you split it up?
No, because it's a sort of. That's what I would do. And then maybe we could split it up. So let's try factoring this. So then it would be x minus x squared minus 1. Yeah. All over x squared plus 1 and dx. Now we could split this into two fractions because we technically, right, have, although it's
We could cancel.
still a product, but then we could cancel. Oh, yeah. Yeah, we just may as well cancel. And actually, I wouldn't have to do anything.
Yeah.
Isn't it 2x?
2x
So,
minus 1 integral without.
Yeah, then it's just x squared minus 1. Here's a sneaky one that came up here. This wasn't an inverse trig at all.
Those jerks.
So, yeah, so now we just have x squared dx minus the dx. So then what would this one be?
X to the third. X to the third divided by 3.
And-
Minus x.
Oh,
Plus
it's
one.
not derivative. JK, we're stupid.
No,
I'm stupid.
I'm going to end this one, and then I'll do one more tape. All right, so come back. We're coming back with some more inverse trigs or maybe some not inverse trigs.